So let me do the screencast. So we have got the idea of what is Kotlin Playground. IDE also we are aware. So development environment, for development, as I told you, Java is needed and any IDE. So we installed IntelliJ IDEA Community Edition, right? Perfect. So you would be thinking, why is Java needed if we are writing the code in Kotlin, right? So if you are maybe a non-technical person, or maybe from the tech domain only, and you are for the first time learning Kotlin, I can understand you, I can feel you. You'd be like, hey Saumya, like we are going to learn Kotlin, we are going to write code in Kotlin, then why are you asking us to install Java? Because Kotlin is a JVM language. Now this is going to be very interesting for you to understand. I mean, if you're going any interview, etc., so this is very important concept. So listen to me very carefully now. So this is kind of usual process. If we write code in kotlin.kt and if you compile it, it is converted into bytecode. It is converted into bytecode. And same thing happens with Java. If you write code in Java and if you compile it, it is converted into bytecode. Okay, it is converted into bytecode. Now after that, if you run it, like JVM can run it and so on. The kind of the process is very much similar to how we do in Java. Basically JDK is Java Development Kit, and JDK is a mix of, it is a combination of JVM and other libraries, etc. This is just for your theory knowledge, don't get confused too much. I'm just going to explain why we install Java, I mean why we install JDK. Okay, it is short answer, long story short, is because Kotlin is a JVM language. Now let me help you understand what is a JVM language and why is Kotlin a JVM language. Okay, so what is a JVM language? Java Virtual Machine is a virtual machine which enables a computer to run Java program as well as other programs written in any other language which can compile to bytecode. Okay, which can compile to bytecode. So basically JVM is a machine which run any program. JVM is a machine which can run any program, that is compiled into bytecode. So we just got to know that Kotlin code can be compiled into bytecode, right? So JVM is that machine which run any program which can be compiled into bytecode. So obviously indirectly it means JVM can run Kotlin code as well. If you save any file in Kotlin language, if you write code in Kotlin and if you compile it, so it will be converted into bytecode. And JVM is one such machine which can run all such programs which are present in bytecode. So Kotlin also when compiled is converted into bytecode, and Java as well when compiled is converted into bytecode. So Java and Kotlin, both of these can be converted into bytecode, and JVM just need bytecode to run the program. That's it. I mean, a JVM compatible language is a programming language that can execute perfectly on JVM, or indirectly you can say which can be compiled into bytecode. So JVM language is any language which can be compiled into bytecode, and we know that Kotlin can be compiled into bytecode, and therefore Kotlin is a JVM language. It's so simple and so easy. Okay, JVM can run anything which can be converted into bytecode, and Kotlin can be compiled into bytecode. Perfect. So here are these steps which I already did. This is a kind of summary for you if you are facing any issue in installing, etc. So the step 1 is you have to install Java. Java 8 is not mandatory, but like yes, kind of minimum you should have is this. And then IDE installation is step number 2. You can install any IDE. I mean, this is not only these three, any IDE. Okay, if you already are using any IDE, you can check that as well. This is a bit of theory here. You can just take a screenshot of this. We wrote the Hello World program, right? Let me explain you what that was. So fun, I already told you, this is a keyword. This is the name of the function, and then inside parameters we can pass inside the braces, we can pass some parameters, right? We can pass parameters. This is name of the parameter, and after the colon, this is the type. This is the type of parameter. Then inside curly braces, you have the body of the function, inside which you can write anything, whatever you want it to do. So main is the entry point. Main is the entry point of any program written in Kotlin. Okay, JVM looks for this method, the main method, while running your program. I already explained this to you, that main is the driver function. Okay, I mean, whenever you will compile it, the JVM will look for main method, then it will line by line execute everything. Perfect. So now let's talk about variables. How can you create variables in Kotlin? So let's say, let me give you a simple example. We recently did a shifting, right? And the company which we had, Agrawal Packers and Mover, what they did is they kind of created boxes, and they wrote some stuff on that, like kitchen, study, books, something like that. So kind of some data was present in the box, and they gave a name to that. Let's say 5 is present, or some stuff is present, and if I call it with the name of a score, so kind of this is the purpose of variable. I mean, to hold data. I mean, some data is present in this box, this box, this box. How will I know that? I mean, how will I call them? So I have to give them some name. I can call them A, B, C, D. Like you have a name, right? Saumya, Rahul, Akanksha, Kritika. So many names are there, right? Everyone is known by their unique name. So in the same way, to store data, we have variables. Okay, simple box that holds the data. Each variable has a name to access the data. Now the question is, can it be reassigned or not? So here is the real thing. In Kotlin we have two things, var and val, to create variables. Okay, let's say I want to create a variable name and give it the name scalar. Okay, give it the name scalar. So name is a variable and the data is a scalar, right? I can also create variable marks. Okay, let's say this is your marks in mathematics out of 100. I'm giving you 99. Okay, so variable and value, right? This is the data. This is basically your data, and to access this data, to access your name, I'm creating a variable. Okay, this is your variable. To access, I'm giving it a name, like to the boxes I am giving names, right? In the same way, to access some sort of data, I'm creating names. So there are two things, as I told you, var and val in Kotlin. So if you create a variable using the keyword val, so it will be kind of constant. You won't be able to reassign it. You won't be able to give any new name. Let's say if I write val name is equal to scalar, right? Scalar. So I can't do like name is equal to scalar academy. Why? Because val is constant. I mean, if you are creating something using val, that means in the entire project, the data, the value of this variable will not change. If you want to make it changeable, then var name is equal to scalar, and then maybe later in the project you can name it scalar academy, something like that, right? Perfect. So var and val, that is a very important concept in Kotlin. Let me quickly show you with the help of code as well. So let's say if I am writing here, let's remove these extra functions for now. I'm removing it. Yeah, so let's say I want to create a variable name, and I want to give it name scalar. Okay, I want to print the value of this, print name. Okay, print name, that's it. So as of now, if I, let's say, give it the name scalar, it will print scalar. Very obvious, right? If I want to change the name later to maybe scalar academy, I can do that very easily here. Now if I run it, you will see here, I'll see scalar academy, right? If I change it to val, it will throw error. What it is saying? It is saying that val cannot be reassigned. This is what I just told you, that val cannot be reassign. If you are creating a variable using a val keyword, you cannot change its value in the project. If you are creating a variable using var keyword, you can change the value anytime. I mean, right now you named it name Scalar Academy. You can again change it to maybe Kotlin from Scalar, learning Kotlin from Scalar. Okay, learning Kotlin from Scalar, and if you run it, you will see that only. So learning Kotlin from Scalar. So as simple as it looks. And now let's get back and see some more advanced concepts here. Basically, these are not advanced, these are fundamentals. I mean, how to create variables. Talking about data types. Now there are types of data. Right now what I did, I created name variable and gave it the value Scalar Academy, right? That was of type string. If I want to store marks, if I want to store my marks, let's say in physics 97, so this is of type integer, right? So these are the data types in Kotlin: integer, floating point, boolean, character. If you just want true or false, boolean is there for integers, short, int, long, byte, float, double, floating point, and then in character char, string, right? These are the data types. And these are some quick facts about Kotlin. Let's quickly check it. So once we will go on and on, create more and more projects or files in Kotlin, we will write more code in Kotlin, you will understand these data types in detail. Let me show you one more thing. Like there are two things basically that you can do in Kotlin. You can specifically tell it the type as well. You can tell it that, hey, you are of type string. You are of type string. Even if you don't tell it, it is smart enough. If you are writing something in double quotes, then obviously it's obvious that, okay, you are giving value of type string, right? Let's say I want to create here marks variable. So I can either explicitly tell it that, hey, you will be of type int, and then give it a value 98 and then maybe print it. Okay, so here I'm explicitly telling it that you are of type int. If you won't do it, it will automatically understand that, okay, this is of type integer. If I do 98.0 decimal, right, so this is floating value, right, floating point, double, float, etc. So yes, let's get back. You will understand more about data types as we write more projects and files, okay, in Kotlin. So Kotlin does not need a semicolon to end statements. You would have noticed by now. It is null safe. So I'll show you some real example that will help you understand better how it is null safe. So in Java, if you have the experience of writing code, if we call something which has null value, like let's say if I'm calling test dot object or something like that, and if something is null here and there, it will throw null pointer exception, right, and that will crash your application. So it is null safe, and it has no primitives, no properties, fields. You can take a screenshot of this and you can study the quick facts about Kotlin from here. These are kind of theoretical stuff, and yes, as of now, till now, you have created your Hello World project in Kotlin. You have you have compiled your first project. You know what is JVM language, you know the basics of it, how to create variables in Kotlin, var, val, the keywords, right? If we talk about operators in Kotlin, there are three types of operators in Kotlin: arithmetic operators, relational operator, and increment and decrement operator. So talking about arithmetic, you have mathematical modulus, like modulus is for quotient. Like let's say if we are doing 13 modulus 2, right? So 13 divided by 2 is 2, 6, 12, 1. So 1 is the modulus here, remainder. Okay, remainder. So yes, arithmetic operators, very much simple. I'll show you by writing the code. Then there are relational operators, greater than, less than, etc. And there are pre and post increment operators as well. So let me show you the concept of operators by writing code. Okay, so let's jump into the IDE now. IDE. So let me remove all this piece of code and show you like how we can deal with operators in Kotlin. Okay, So let's say I have a variable A, it has value 10. Variable B, it has value 5. Okay, so I can do multiple operations here, like A plus B, whoops, inside this, A plus B, or you can do print ln A minus B. Okay, A minus B, and the same way you can keep on writing, like you can write other operators as well. You can try multiplication, division, everything. A into B, multiplication, right? Print ln A divided by B, A divided by B, and if we run it, so it should show us the value of all these. You can see 10 plus 5 is 15, it is showing us 15. Then 10 minus 5 is 5, then 50, and division 10 by 5 is 2. You can also print here A modulus 5, that will A modulus B, sorry, that will give you the value of the remainder, right? You can see here it is 0 because 10 divided by 5, 0 is the remainder, right? Perfect. And yes, that way you can try out other operators as well. These were arithmetical operators. Relational operators are also kind of same. Let's say you want to check if A is greater than B or not, right? They are telling that this is obviously like true because 10 is greater than 5. So let's check what it prints here. So it is printing true, right? You can in the same way test out other relations as well, like is A less than B? So it is obviously always false because 10 is not less than 5, right? So in this way, I mean, multiple relation operators are there. You can check if this is equal, A is equal to B or not. That way you can check out other operators as well. Relational operators. So these were arithmetical operators. These are relational operators, right? And now let me show you the magic of increment and decrement operator, right? So if I do A plus plus, this will do exactly what A is equal to A plus 1 will do. So basically A plus plus or maybe A minus minus, these are increment and decrement operators, okay? And here as well you have two things, post increment. Okay, let me explain you here. So pre-increment, pre and post, okay? Let's first understand what is pre. Pre means before, right? So if you write plus plus A, so what it will do is print ln, let's say print ln and plus plus A, okay? Whoops, plus plus A. So here as soon as you write plus plus A, it will quickly increase the value of A. It will print 11 here, okay? It will print 11. Let's run and check. So it printed 11, right? If you write plus plus after A, that is your post increment. Let's write it here only. This is your pre increment. Okay. Whoops. This is pre. This is coming before the variable name, right? If I write plus plus after the name of the variable, so what it will do, as of now it will remain same, I mean A plus plus. So at this point it will show me the exact value of A, and if I print it later, then it will tell me that hey, the value is now 11. I mean it will increment the value but after some time, right? Print ln, so see here it printed 10 and then 11, okay? And once again if I do here plus plus A, so it will at that point only immediately it will increase the value. Here also it will print 11 and here as well it will print 11. Right now it is 10 and 11, you can see, right? 10 and 11. If I run it again, so it will tell me 11 and 11, okay? So basically that is the power of pre and post, okay? And plus plus means it will increase the value by 1 and minus minus means it will decrease the value by 1. Very simple and straightforward. Nothing nothing confusing here. Let me know in the comment section if all the pointers still here are clear. Variables, you now know how to create. Var a is equal to this, right? Val also you can use if you want the value of b to not change in the project, you can call it val. That's it. And then we talked about 3 types of operators as well: arithmetic operator, relational, and these are pre and post increment and decrement operators, right? So yes, I mean, I hope by now you have got a basic idea of Kotlin. We talked about the basic stuff, and in the coming modules we'll deep dive into more advanced concepts. Classes and objects in Kotlin. Kotlin is an OOP language, object oriented programming language, and it is a paradigm which allows us to solve problems with the help of objects, which represents the real world entities. This is object oriented programming language, and in such languages object play very significant role, and classes and objects are kind of integral part of such programming languages. So if you talk about classes in general, so class is a blueprint or a template, you can say, and objects are the real thing. You create objects in your program and they interact with each other to complete the work. This is a bit of theory and might be right now you are not clear of what exactly class is, what exactly objects are, right? So I'll give you some examples and that will help you understand things in a way better manner, okay? So if you see this picture, it contains mobile 1, 2 and 3, right? And all these are different in terms of their size, color, battery type and features, right? Might be this is phone from MI company, Oppo and so on, right? But can you imagine what is the general thing about all these 3 types of phone? So yes, all these 3 are mobile phones, right? If we want to put all of these in one category, we can say mobile phone, and these 3, the Oppo phone, MI, all these are mobile phones, cell phones, right? So if we have a class of mobile phones, then we can have objects 1, 2, 3 which are of different companies, right? So this is how the concept of classes and objects are. To make it more clear to you, let's say if you have a class of car type, then inside this you can have multiple objects, right? You can have object of type Ford, you can have object of type BMW, you can have object of type Tata, etc. I mean, so many cars are there, right? So yes, I mean, that's how the concept of classes, and inside that objects, all the objects will be somewhere related to that class. Like all these are related to this class mobile phone. These all are mobile phones only, right? In the same way, all these objects, object 1, 2, 3 are of the same type. They are car only, but obviously the features, the color, everything will be different, the price and all those stuff, right? Perfect. So before you create objects in Kotlin, you need to define a class. A class is a blueprint for the object. We can think of class as a sketch or prototype of a house. It contains all the details about the floors, doors, windows, etc. Based on these descriptions, we build the house. House is the object, okay? Since many houses can be made from the same description, we can create many objects from one class. Might be in 2 objects, the only differences of color, they are all same, but they are of different colors, right? Perfect. How to define a class in Kotlin? Now let's see the syntax of classes in Kotlin. Very important. So we use the keyword class, okay? We use the keyword class, and after that class name based on your need. Let's say if you are creating a class for car, you are creating a class for people, for objects, anything for that matter, right? So class keyword, this is keyword, and then this is the name of the class, right? And then inside this you can have multiple properties, You can have member functions, you can have variables. Like for people class, you can have name as one of the variables, age, gender, and so on, right? Awesome. So I hope the concept of class is a bit clear to you now, right? You would have got a basic overview or of idea of what classes are. If car is a class, then you can have objects like BMW, Ford, and so on, right? In the same way, if you have person as the class, you can have multiple objects, object person 1, person 2, and so on. Awesome. Here is an example of the same. This is class lamp, and inside this you have some member functions as well as some variables, right? So this is var is on, this is of type boolean. Private is the modifier, visibility modifier. I'll talk about it shortly. So var keyword you already know. Is on is a variable, and we have given the value false to it. So lamp is on a kind of variable which tells if the lamp is on or off, right? True means is on, false means it is not on. And then we have member functions as well. We have turn on function. So obviously if you'll call this function, then the lamp will be turned on. If you will call turn off function, then the lamp will be turned off, right? Perfect. So here we defined a class named lamp. The class has one property, is on, defined in the same way as variable. Obviously we just saw this. And you have two member functions as well, turn on and turn off. These two are the member functions. These two are functions. And here we have one var, one variable. Alright, moving ahead. Classes, objects, properties, member function, etc. can have visibility modifiers. Obviously, like we just saw private here. Private, by default they are public. So for example, the is on property is private here. This means the is on property can be changed from only inside the lamp class. That is, that variable is private, that can only be changed from inside that class in which it is created, in which it is declared. Other visibility modifiers include like private, obviously you just used, visible from inside the class only, public, visible everywhere, protected, visible to the class and its subclasses as well, internal, any client inside the module can access them. So you will understand more about these modifiers, etc. once you will start writing code, more and more code, right? So if you do not specify the visibility modifier, it will be public by default, as I just told you. And in the above program, turn on and turn off member functions are public, whereas the is on property is private. So basically they are saying is on property is private, but these two member functions, turn on and turn off, are public because we haven't given any visibility modifier to them. Now let's talk about Kotlin objects. Before that, I hope you remember the syntax of classes. Basically you just have to do like this. A class keyword will be there, and then the name of the class, name of the class based on your needs. And inside this you can have data members, or you can call them data variables. And apart from that, you can have data functions as well. Moving ahead, let's now talk about Kotlin objects. When a class is defined, only the specification for the object is defined. No memory or storage is allocated. So we just created this class lamp, right? So when the class is defined, there is no kind of memory or storage is created for that class. If you want to access the members, defined within the class, like is on or turn off, if you want to access these, you need to create objects, okay, objects of the class. And the syntax is pretty simple. So you know that this is the class, okay, class lamp. One second, yes. So this is the class lamp till this point. This is main function. Whenever I'll compile the program, so the compiler, what it will check, it will first of all check the driver function, that is the main function. Now if you see the first piece of code here, first line of code here, number 1, val, which is a keyword, L1 is equal to lamp. Basically here I created L1 object of lamp class. Okay, what it will do is it will create some storage for us. I mean, if I want to, let's say, access the property is on, so I can say L1 dot is on. L1 dot is on. If I wanted to access, let's say, this function turn off, so turn off, something like that, using the dot operator. This one is called dot operator. I can access the data members and the member functions inside the class. Okay, awesome. So this is the way we create the objects, val or var, anything, name of the object, object 1, 2, whatever you want, and after that the class, whichever class you want to call, something like this, like lamp. Okay, this program creates two objects, L1 and L2 of class lamp. The is-on property for both the lamps will be false. The is-on property for both the lamps L1 and L2 will be false, because obviously in the starting, while we created the class lamp, we set the value of this variable is on as false. Moving ahead, how to access members, I already explained you. You can access properties and member functions of a class by using the dot notation, dot operator. For example, L1 dot turn on. This statement calls turn on function for the L1 object. Let's take another example. So L2 dot is on is equal to true. So basically what we are doing is we are calling the is on variable from the L2 object, and we are setting its value as true because initially it was installed as false, right? So here we try to assign true to is on property of L2 object. Note that is on property is private, and if you try to access is on from outside the class, an exception will be thrown, right? Now here is an example of Kotlin class and object again. So this is the same example. If you see, so this is the content of the class lamp. We have turn on function, we have the turn off function. Apart from that, we created a new function, that is display light status, right? Depending upon, like, we'll pass some string variable, and then we'll check if is on is equal to true, then it is on, otherwise it's off. So here it's important to understand what we are writing. Okay, let's see. So function main is the first thing to be executed when the compiler runs a program, right? So val L1 is equal to a lamp. Basically we created L1 object of lamp class, and then we have L2 object of lamp class. So L1 dot turn on, we are calling L1 dot turn on, so it will go and do this, is on is equal to true. So for L1 the value of is on is true, right? So when I will do L1 dot display light status, so is on is true, so it will print that this lamp is on, right? L1 lamp is on. And for L2 I am calling turn off, so the value of is on will be false, and therefore when I will call display light status by passing the L2 object, then obviously is on is not is equal to true, so it will print lamp is off. Perfect. It's very simple. I mean, behind the scenes also is very important to understand. So let's say when you are creating an object like Mustang, Beetle, anything for any of these classes, like if the class name is car, so as soon as you create the object, memory is given, memory is allocated to the particular class, depending upon how many member functions, how many variables are present in that particular class. And let's now write some classes, some objects in Kotlin to understand this concept in even better manner. Perfect. So now let's create a class of name. Maybe you can create my class, in which we will create objects and classes and see the syntax of classes and objects in Kotlin, right? So I'm going to create new, and here is Kotlin class in file. I will name it my class, and it should be of type file. Then I'll write function main, because obviously main function is the most important thing. I mean, whenever you will click this green run button, so main function is the first thing which the compiler executes, right? So here we will create object of the class, object of the class. We know the syntax very well. Before creating the object of the class, obviously the very first thing is we have to create the class itself, right? So the syntax of creating class is very much simple and straightforward. You have to use the keyword class, and after that the name of the class. So right now I want to create a class of name person, and here what you can do is, like we in the syntax read that we can have curly braces, right? And inside the curly braces we can have data variables, we can have member functions, and like variables as well as functions, right, of that particular class. So here if you see, I can have curly simple parentheses as well, and inside that I can pass on values while creating the object of the class, right? So what I will do, I have the person class. So person class can have variables like name of the person, age of the person, gender of the person, and so on, right? So let's say I want to create a variable name, okay? So var name which should be of type string, okay? And after that var age, and that should be of type int, and so on. You can create multiple variables here, right? Name, age, and depending upon the person class, what kind of variables, member functions it can have, you can go on and on, right? These are the properties, the data variables, and you can create these inside the class as well. But for the ease, I passed these here itself. Just in next few minutes I'll teach you why I did that and why it's important in Kotlin, and how it's related to the concept of constructors as well, okay? Perfect. And here I will create one function, can vote, okay? Can vote, can vote, and I will accept the age variable, the parameter, and inside this I'll check if age is less than 18, then I will print here, cannot vote, else if the age is I can simply go on writing else if the age is greater than if it's less than 18, then cannot vote, otherwise print ln, I will say can vote, okay? Can vote. Awesome. So I have the person class ready, and inside that I have one function, can vote, and the two properties, two data members are name and age, okay? Either you can pass these variables inside the person class, or the way I have done it in the parenthesis as well. So I'll create object of the class person. So var object1, or you can say person1, so obj1 is equal to person, and here I have to pass some properties, right? So the first name I'm giving here Saumya, and I'm giving here age 22, okay? And after that, to call other member functions, variables, I'll say object1 dot, you can see here I have multiple options. I can call name, age, or can vote. So I want to call can vote, and I'll pass here 22. So if I run this piece of code, you will see that it will print can vote. Why? Because the age passed here is 22, right? 22. So what it will do, it will call this function, and it will check here if 22 is less than 18, it is not less, so we'll come here and print can vote, okay? So it's as simple as it looks. Creating a class, the syntax is very simple. The class keyword is there, name of the class. Inside parenthesis you can pass some variables, and you can do the same thing like after creating the class person, and inside like function can vote is here, right? So you can similarly have some variables here as well, name and so on. So it depends on you. I did it because I wanted to pass values here via the object only while creating the object. It looks better. I mean, depending upon the use case, you can change the way you create the class, you can change the way you create the objects, and so on. And now let's get back to the iPad, and I'll teach you some more important concepts around OOPs, around classes and objects. So now let's talk about constructors in Kotlin, yet another very significant concept, right? So Kotlin constructors. A constructor is a concise way to initialize class properties. Like I just now created the person class, and inside that I had properties like name, age, can vote, etc. So if I want to, let's say, initialize the values like name, age, and there can be like multiple values. So for those, constructor is very important. If anyone asks you what are constructor, so they are very handy, they are concise way to initialize the class properties. It is a special member function that is called when an object is created, when the object is instantiated. However, how they work in Kotlin is slightly different. In Kotlin there are two types of constructor: primary constructor and the secondary constructor. So talking about primary constructor, the primary constructor is part of the class header itself. This is a good example here: class person, and then we have variables here, first name and age, and this is the class body. So the block of code surrounded by parentheses is the primary constructor itself. This much block of code, this much piece of code which is surrounded by the simple parentheses, that is primary constructor in Kotlin. Okay, so I just created this similar kind of class, right? So in that, the class header itself is containing the primary constructor, right? The constructor declared two properties: first name, read only property, as it is declared using the keyword val. Okay, and then we have age, that is read write property, since it is declared with the keyword var. I hope you remember var and val, which I taught in the starting of the course in module 1, right? So this is again example of primary constructor. Function main is here. I created person1, the object of the class person. I passed Joe 25 as the value of the parameters first name and age, right? So here I am trying to get the value of the person and the age as well. So person1 object dot first name and object dot age, it will print the value of the variables, right? Perfect. Primary constructor and initializer block. So the primary constructor has a constrained syntax and it cannot contain any code. So as you just saw, the syntax of primary constructor is quite like restricted, kind of. Only this much part, I mean, after the name of the class, in parenthesis you can pass parameters. That is the primary constructor. It is in the header of the class while creating the class. So it cannot contain any code, we just saw. To put the initialization code, not only code to initialize properties, initializer block is used. It is prefixed with init keyword, and if we try to modify the above example, so it will look something like this. Function main, right? We created one object person1 for the class person, and we passed two values. So here we passed Joe and 25, right? Then I have first name and age as the data member for the class person. Then I have initializer block in it, and inside this what I am doing, I am initializing the first name. You can see here first name is equal to fname dot capitalize, and then age is equal to person age, whatever we are passing here. So the value of first name will be like, if assume this is the value, so Joe in capitals because we are capitalizing here, and 25, right? And if you print here, so obviously you will get the value which we passed, right? Perfect. So I mean, it is the example of initializer block in it. If you want to initialize something, not only initialization, but you can do much more than that. You can use init block, because we saw that the kind of freedom given to primary constructor is quite constrained, right? So you can use the init blocks as well. And moving ahead, when you run the above program, the output will be first name Joe and age is 25. Age is 25. So here parameters fname and person age, inside the parenthesis accepts value Joe and 25. Obviously these fname and person age, they accept the values which we pass from here, right? And after that When person1 object is created, however, fname and person age are used without using var and val, they are not properties of the person class. They are not properties of the person class. The person class has two properties, first name and age, as declared here inside the class person. And when person1 object is created, code inside initializer block is executed. So if you ask when this init block is executed, it is executed as soon as you create the object of the person class. When a person1 object is created, the code inside initializer block is executed. The initializer block not only initializes the property but also prints them. So I hope the concept is clear now. The fname and person age inside the parenthesis, that is this one, they accept the value that we passed from here while creating the object, and when the object is created, it executes the init block which is here, right? Awesome. And here is another way to perform the same task. So we have the function main, and in this we are creating person1 object which is of type which is for the person class, right? And we are passing two values here. And if you come here, you can see fname and person age, they are here to accept the values that we are passing while creating the object. And here first name and age, I am initializing them. Inside init, I'm just printing stuff. To distinguish the constructor, parameter and property, different names are used, like fname and first name, person age, etc. It's more common to use these kind of variable names. So when you will run the program which is written here, so output will be something like this. And when the object of the person class is created, Joe and 25 values are passed as if the person is a function. And that's the beauty of classes and objects in Kotlin. Like here we created the class in the way a function is created, right? And that's why it was able to accept the values when we passed while creating the object. The same thing is written here. This initializes the first name and age properties of person1 object to Joe and 25 respectively. Moving ahead, primary constructors, they are very simple and easy to understand. They're kind of inbuilt. In the class header only the primary constructors are there. If we talk about Kotlin secondary constructor, so in Kotlin a class can also contain one or more secondary constructor. They are created using the constructor keyword. Secondary constructors are not that common in Kotlin. They are not heavily used, but yes, it's important that you understand what are Kotlin secondary constructors. The most common use of secondary constructor comes up when you need to extend a class that provides multiple constructor that initializes the class in different ways. So here you can create a secondary constructor in Kotlin this way. Here is the syntax. So let's say the class name is log, right? If you want to create secondary constructor, use the keyword constructor, and then you are passing one parameter, then constructor keyword, and you are passing two keywords here, parameters here. Here the log class has two secondary constructor but no primary constructor at all. You can extend the class in this way. If let's say class log is there, it is having two constructors, right? You have auth log, another class which is inheritance is basically going on here. It is inheriting from log class, right, which is created here. So you can see that can inherit the constructors as well from the parent class. Here the constructors of the derived class auth log calls the corresponding constructor of the base class log, and for that super keyword is used here. As you can see, super keyword is used, right? So secondary constructor in Kotlin is not that heavily used, very less, and to create you have to use the constructor keyword. That's it. Apart from that, primary constructor are very common, and you just saw multiple examples of it. It's kind of primary constructor. It is one of the concise way to initialize the class in Kotlin, and the syntax you understood already. Moving ahead, By now you know how to create class in Kotlin, how to create objects, and when objects are created then only some storage is allocated, right? And you can call the data members, the member functions of the class using the object only. You know what are constructors and types of constructors in Kotlin. Moving ahead, let's talk about Kotlin getters and setters. So in programming, getters are used for getting value of the property, and similarly setters are used for setting the value of the property. If I want to, let's say, set the value of some variable to maybe a scalar, right? So I can simply do that with the help of some syntax, and that's what we are going to see, what are getters and setters in Kotlin. So in Kotlin, getters and setters are optional and are auto-generated if you do not create them in your program. So if you do not create them in your program, they will be auto-generated, right? So how getters and setters work? The following code in Kotlin, if you see. So class person and var name, we are creating a variable of type string and we are giving it default value, right? This one is equivalent to this piece of code. Class person, we have name variable of type string and we have some default value here. So if we are not creating getter setter, by default it is being created there. If you see here, get is equal to field getter and setter in this way, set value and field is equal to value. So if you write this much piece of code, you can assume that getters and setters are by default created in the background in Kotlin. Example, let's understand this one. Quite lengthy piece of code, but it's very, very simple. I mean, nothing difficult is there. Whenever you feel that any piece of code is difficult, just start executing it. Start doing dry run of it and it will become very, very simple for you to understand. So obviously, fun main, the compiler will start from here. Val Maria is equal to girl. So basically what we are doing here, we are creating Maria object for the class girl, right? Maria.actual age is equal to 15. So I am calling the actual age parameter. So let's see how many parameters are there in class girl. So age is there and then actual age is there, right? For age we have written some piece of code, getters and setters, right? So here get is equal to field and set is equal to value and field is equal to 18 if value is 18, otherwise something like this, right? Now they have written a lot of getters and setters code, right? So let me erase this and now let's see here. So Maria.actual age is 15. So if I'll print this, obviously I should be getting 15 and I'm getting 15 only, right? I'm getting 15. But if you see here, Maria.age is 15 and for age I can see I have getters and setters available here. So it is doing some change here. If value is less than 18, so for me it is less than 18 only. So it is saying that field is equal to 18. I mean, it is changing the value, and that's why when I am later on printing Maria.age, I am getting 18 as the output, right? Same way, let me again do a dry run of the other piece of code that will help you understand better. So here what I am doing is I am creating Angela object of type girl, right? Angela.actual age is equal to 35. I'm calling actual age and I'm setting its value as 35. So when I will print it, it should give me 35. Right? This much part is clear. After that, Angela.age is equal to 35. But here if you see, 35 will be passed, right? So if value is between 18 and 30, this will be the case. Otherwise, I will fall in this case because the value here is 35, right? And 35 is neither less than 18, it is neither between 18 and 30. So obviously this piece of code will be executed. Value will become value minus 3, that is 35 minus 3, 32. So when I will do Angela.age, so 32 should be printed, and yes, 32 is printed at the end, right? So basically what we are trying to do here, we are trying to write getters and setters on our own. By default, getters or setters are obviously always there, but here we are trying to do some extra piece of stuff using getters and setters. These are also not kind of heavily used, but yes, you must know what getters and setters are. Basically, getters are used for getting value of the property and setters for setting the value of the property. Moving ahead, late init in Kotlin, it's very important. I mean, in one of my interviews as well, I was asked about this. What is late init in Kotlin? Okay. So if you see here, I'd prefer explaining this with the help of one practical code. So basically, late init, if you try to break it down, late meaning later, something which is done later on, and init means initialization, right? So it means we are somewhere telling the compiler or the system that I will initialize this late. Now I'm saying I will initialize this late. What is this here? So whenever we create variables, right? Whenever we create variables in Kotlin, so in the class, they ask us to either initialize them, either give them some value, else they will throw error that the variable is not initialized, right? So if in case I don't know the value of the variable in the starting of the program, in the starting of the project, but later on maybe I'll give it some value. So in those cases, I can put late in it. That hey, I will give it some value. I will initialize the name variable, but later on in the program, later on in the project. Let me quickly give you an example, and that will make things better and easy for you to understand. So let's say I'm taking this example only. Okay, I have the main function and I have the class person. Inside class person, if let's say I want to create one variable profession, okay, profession. So you can see it is throwing some error that property must be initialized. I should give it some value. This is of type string. Still it is throwing the value, right? That it must be initialized. But at this point I don't know the profession, right? And I don't want to keep it empty. So I can add here late in it. And the error is gone, right? Basically I told the compiler, I told the system that hey, I will give some value to profession, but later on, late in it, I will initialize it, but later on in the project. So later on when I'll feel like okay, I can give this value to profession, I can give that, right? So this is the use case of late in it. If you break it down into two parts, late and in it will become self-explanatory for you. Perfect. And now let's get back here and try to understand some more significant concepts.